You will need the following instruments to implant a MAGNEZIX compression screw 3.2, a guide wire, the measuring device, the cannulated drill bit, the cannulated countersink, a small insert drill sleeve, a double drill guide, and the screwdriver. To determine the length of the screw, slide the measuring device over the inserted guide wire to the bone. The end of the guide wire, visible in the scale of the measuring device, indicates the length of the screw. Position the guide wire through the double drill guide with the drill guide attached. Make sure you use the correct color-coded tools here. The drill guide must be removed before you drill the pilot hole to the desired screw length using the cannulated drill bit directed by the underlying guide wire. To make it easier to insert the screw head, use the countersink to enlarge and bevel the point at which the head of the screw will sit flush with the bone surface, meanwhile making sure that the guide wire is still in place as you do this. Make sure you use the correct color-coded tools here. If the screw is being positioned perpendicularly to the bone surface, you only need to countersink to the first ring marking. If the screw is positioned obliquely to the bone surface, countersink to the second ring marking to ensure the screw head lies flush with the bone. Screwdrivers are available with a one-piece or multi-part handle. To assemble the screwdriver, insert the screwdriver blade into the one-piece or multi-part handle. Press the cap at the end of the handle to secure the screwdriver. This overview shows a complete MAGNEZIX pin instrumentation set for all dimensions from 1.5mm through 2.0mm and 2.7 to 3.2mm. Instruments for different dimensions are color-coded. You will need the following instruments to implant a MAGNEZIX pin 3.2. A 3.2mm reduction wire, the measuring device, a 3.2mm drill bit, the depth gauge, a double drill guide, the impactor with sleeve, insert and screw-in tip, and the optional hammer with plastic insert. If the reduction wire has been used for temporarily stabilizing the fracture situation, the length of the pin can be determined by advancing the measuring device over the reduction wire up to the bone. All instruments compatible with the different dimensions are color-coded to ensure the correct instrument is used for each pin dimension. To prepare the 3.2mm impactor, the blue-coded impactor tip is screwed into the blue-coded impactor sleeve. The impactor sleeve can now be loaded with a 3.2mm pin. The impactor insert is inserted into the sleeve. Gently press the impactor insert to make the MAGNEZIX pin appear at the impactor tip. Only the impactor insert is used for the last few millimeters of the insertion process. The recess in the head of the pin helps position the insert centrally. This recess also reduces the risk of the insert slipping off the pin head. This ensures a better view of the implant. This video describes the treatment of a malleolar fracture to the distal tibia using a MAGNEZIX compression screw 3.2 and a MAGNEZIX pin 3.2. Before the MAGNEZIX screw can be implanted, the bone fragment must be repositioned and temporarily stabilized. Position the guide wire through the double drill guide with the fitted drill guide until it is in the required position. If necessary, monitor using an image intensifier. Avoid using excess force when inserting the guide wire. This will bend the guide wire and make it difficult or impossible to ream or insert the screw later on. The 3.2 mm reduction wire is inserted into the bone through the double drill guide. If necessary, check the depth using an image intensifier. Use the measuring device to check the depth of the reduction wire. In our case, the depth is 42 mm. Use the appropriate measuring device to determine the length of the CS 3.2 compression screw. In our case, the length is 36 mm. At least 2 mm must be subtracted from the measured length to ensure that the guide wire does not detach from the bone during the subsequent pre-drilling process. In this case, we will therefore use a CS 3.2 with a length of 34 mm. The hole is drilled over the guide wire to a depth of 34 mm. The calibration of the drill bit makes it easier to read the drilling depth. Each of the fine rings represents a depth of 2 mm. Each of the deeper rings represent a depth of 10 mm. Once you've finished pre-drilling, leave the drill bit turning slowly in a forward direction and pull it out vertically from the drill guide to ensure that the guide wire remains in position. To make it easier to insert the screw head, use the countersink to enlarge and bevel the point at which the head of the screw will sit flush with the bone surface, meanwhile making sure that the guide wire is still in place as you do this. In this case, the screw is not perpendicular to the bone surface. As a result, the head space must be enlarged to the second ring mark to ensure the screw head can be completely countersunk. The 34 mm MAGNEZIX CS 3.2 screw can now be inserted over the guide wire. Make sure that the guide wire has not been damaged in the previous steps. If the guide wire has been damaged, it may not be possible to fully tighten the screw. In this case, the guide wire must be removed before the screw is fully inserted. If too much compression is generated while the screw is being tightened, this could pull out the screw thread in the far fracture fragment. If the screw is too short, the thread of the shaft might cross the fracture or osteotomy gap. In this case, no compression will be generated. We therefore recommend using an image intensifier to check that the shaft thread is positioned correctly. When you start tightening the head, you can now see the compression being exerted on the fracture gap. After this, remove the guide wire. Then remove the reduction wire. A 42 mm pin is inserted into the impactor sleeve. The impactor insert is then inserted into the sleeve and pushed forward until the pin appears at the impactor tip. The tip of the MAGNEZIX pin can now be positioned in the pilot hole. The pin is now carefully impacted into the pilot hole using a hammer if necessary. Make sure that the pin does not get stuck when it is being impacted. The impactor sleeve protects long pins in particular against bending. We therefore recommend that you use the impactor. Only the impactor insert is used for the last few millimeters of the insertion process. This ensures a better view of the implant. The recess in the head of the pin helps position the insert centrally. This recess also reduces the risk of the insert slipping off the pin head. The fracture has now been treated.